Hello everyone, how are you? Hope you all are doing well. Myself Radha Kumari, senior maths teacher from More Than Marks, and today I am going to discuss a very interesting patterns. Before starting this, do you know anything about patterns? Like what are patterns? Different kinds, like in our environment as well, we saw lots of patterns are here. Like look at the background of my here. Background one. This is also like some type of pattern, right? This flower, like this petals of these leaves, like they are also forming one kind of pattern. So today we are going to discuss some beautiful patterns, one very interesting pattern. So let's go to the PPT and then I will explain all these things. Okay, let's go. So here we are on the board and see. Look at this amazing picture, how beautiful it is now. So because nature teaches everything. So look at here and yes, next see this amazing like peacock. Wow, what a wonderful like sunflower. Then we have corns and see the hub like honeycomb. So from all these pictures, can you guess what why I am showing these pictures to you? Anyone, like, do you have any idea why I am showing it to you? Yes, I am showing it to you because of these beautiful patterns that they have, right? Look at this, the pattern of like fur of this peacock, petals of these flowers, they are arranging in a very sequence manner. Then the corns, a single corns, like they are forming a sequence. Again, the honeycomb is again they are forming a sequence. So today we are going to discuss this sequence. And what its name is, like I will explain it to you in the next slide. So this is an arithmetic progression. The patterns that I shown to you in the previous slide, they are forming an arithmetic progression. What do you mean by this progression? Progression means anything that is increasing, decreasing, or it will be constantly. Fine. So let's take an example of, let's suppose, of your report card. In your report card, what they are showing, your progress, whole year progress, right? So let's suppose, let's take a subject of maths, and in 3 examination, you are scoring like 30, then 40, and then 50. In this way, like your score is improving, you are progressing, right? Now let's take an example, like in first exam, you scored 50, then 40, and then 30. Now in this case, your progress is decreasing. Right, your marks is decreasing. Third case, like you scored 30, 30 and 30. Now in this case, your mark is constant, like your whole year performance is constant. So these kind of series or these kind of patterns are called arithmetic progression. Fine. So let's go to the next slide. Yes. So our objectives, what are our objectives of this classes? Objectives like why we need it, daily life examples, conditions to be an AP. So we are going to discuss all these things. Next, need of an AP. Why we studied it? Like as we are doing math and we are in more than marks, like we are thinking above more than marks. So we need to know why we are learning AP series. What is its use? So let's consider these examples. The candles, every year candles get increased by 1 as your age is increased by 1, right? Similarly, look at this auditorium, or you can say like the picture hall. Let's suppose let's see the arrangement of the chairs, like seats in the hall. So in this form, if you want to determine the number of audience or the member in the auditorium can hold. So in this first step is what, like first you can do, like you can count the number of seats, but this takes a lot of time. It's just a wastage of time, right? But by using arithmetic progression concept, you can find the number of seats very easily. Fine. Again, the second example is now consider the second example, like you are like stacking the logs of wood. In this stack, if you want to find how many total logs are there, or you want to find how many logs are in the second row or third row. So for this also you can use the concept of heap. Fine. Now let's consider new examples. See, a theater has, like, let's suppose a theater has 20 rows. First rows has 18 seats, and the successive row seat is like increased by 2. So in this case, how you count the number of seats in the last row? So first method is to just go and count the number of seats. But without going there, you can find it by using the concept of APC. I will explain you how we find it, all these things. So let's go to the next. Some more examples are here, like your saving scheme. In your saving scheme, let's suppose you are, so look at this saving scheme example. In this, what we are doing, like we are saving 1000 rupees every year, and it's get increased by rupees 50. So thus they are also forming a series of like AP series, 1000, 1050, 1000, 1100. So like this they are forming. And if I want to know, like after 10 years or after 5 years, I received how much money. So in that case also we use the concept of AP. So I'm just explaining the need why we are studying it, right? So next is, like, let's take one more example. See, the ladder. Building a ladder with a sloping slide, length of each rung. The rung is like this. Length of each rung is forming a arithmetic progression. Like this is the greater one. Like length of this rung is more as compared to this, then it's decreasing. Fine. So again, the rung of these ladder is also forming an ABC. Now. See, now what is arithmetic series? What is its definition? So it's what? It is a collection of number. What? It is a collection of number in which each term, like every term, is obtained by adding a fixed number. Just focus on it. By adding a fixed number to the preceding one, to the preceding term, except the first. So like when I formulate this, it means like first term can be any number. Like let's take it 30. Fine. After this, like what we have to do, we have to add a fixed number to the preceding one. So let's take this one is preceding. I am adding, let's suppose the fixed number is 10. So when you add 10, next number will be 40, right? Again, what we do, like we again add 10 to the preceding number so that we get the next term, that is 50. And again the same process, like adding 10 and you get 60 and so on. So this kind of series or this kind of pattern are called AP progression or AP series. Fine. Do you understand this? Like AP series what? It's just a collection of number, a series of number in which every next number is getting by adding a fixed number to the preceding. So you can also see like the difference between the consecutive terms is same in the whole series. If you have to identify whether it is a AP series or not, in that case you need to check the difference. What? Difference between the consecutive terms. If difference between the consecutive terms are same, then you can say this is an AP series. Fine. Hope this is clear to you what is an AP series and where we use it, right? And why we learning this. Now next. See. Next is what? Again a real-time example. Let's suppose your mom. Let's suppose your mom is giving you a pocket money and you used to save some of the money and you save it in the bank. First year, let's suppose you save 500, and in second year 600, 700, and fourth year 800, and so on. So let's observe this pattern again. So in this pattern again, you are getting the next term by adding 100. First year you saved 500, then in next year you save 100 rupees more than the previous year, right? Similarly, so what is happening, for every year you are saving 100 rupees more. So this is also an AP series, right? Similarly, example 1, 2, 3, 4, this is also an AP series. 3, 3, 3, 3. Do you know, can you tell me, is this an AP series or not? Yes, definitely this is an AP series, because 3, 3 and 3, for according to the definition, we are just adding what? We are just adding fixed number, that is 0, for getting the next term. Again I am adding plus 0 for getting the next term. So this series also follow the definition, rule of definition, or you can say the rule of AP series. So yes, 3, 3, 3 is also an AP series. Fine. So can you give me one example, a real life example from your side? any from your surroundings, like if you know, if you get with any example, then you can comment me like yes, this is an AP series. Okay, now let's move to the next slide. Sequence. What is sequence? Like AP is also a sequence and normal sequence. So what is difference between both of them? So sequence is what? It is also a collection of numbers. You can say like it is also a collection of number. But the difference is there are the terms, between the terms there is a specific relationship between the consecutive terms. In general, that is called sequence. Let's look at this example. 1, 3, 5, 7. What is like specific relationship between these terms? Yes, you are getting every term by adding 2, 2 and 2. It means we are adding a fixed number to get the next term. So this is an AP series as well as sequence. Fine. Now look at this example. How you are getting next term? For getting next term, like it's a multiple of 3, right? 2 multiply 3, then you are getting 6. Again like 6 multiply 3, then 18, and then multiply 3, that is 15. So the specific relationship between them is multiplying with 3. So this is, yes, definitely this is a sequence, right? Because they are following this rule. But for AP, we need to check the difference. Is difference same? Like here 6 minus 2, that is 4, difference is 4. 18 minus 6, that is 12. So difference is not same in this case. So this is not an AP sequence. This is a simple sequence but not an AP sequence. Fine? Is it clear to you ki what is difference between an AP sequence and a normal sequence? Right? Okay. Now, let's move to the next slide. So arithmetic progression, this is I think clear to all of you. If the two successive numbers, their difference between the two successive numbers should be same. If it is same, then you can say they are an AP series. Like in this example, how you get the difference? Difference is 2. In this case, difference is 5. So they are a sequence, AP sequence. So now you are able to identify which one is AP sequence and which one is not. Just find out the difference between them, the consecutive terms. Fine. Now, types of AP. There are two types of AP. First one is finite and second one is infinite. The word itself tell you about like which kind of sequence, or you can say which kind of AP is. Finite means that is having a fixed number or fixed number of terms, countable terms, or you can say the series that will be terminating. That type of series is called AP. Let's see, then let's look at the example. Like it started with 20 and ended at 63. So we can easily count the number of terms in between them. Yes. So that's why they are called finite AP, which is having terminating, or you can count the number of terms it has. Similarly, infinite is one. Infinite is opposite of finite, which has non-terminating and non-countable terms. Like look at this example. It started with 8 and there is no end. So we cannot count the number of terms it has. Right? Similarly, in this, it started with 12 but we don't know the end. Then again we are not able to count this. Fine? So this is the two type of series, that is finite and infinite. Now look at some of the terms, that is first term and the common difference. First term is what? First term is the starting term of any of the series. Like in this 20 is first term, in this 8 is first term, in this 12 is first term. So first term is represented by A. Because it is an AP, so we take the initial letter, that is A. So first term is expressed by A and common difference is expressed by D. Fine, common difference, D for difference. What is common difference? Common difference is just the difference between the terms. So common difference can be negative, positive and zero. Right? Let's look at this example. D, how you find the D? Let's suppose like this is your term 1, A1, A2, A3 and A4 and so on. So if you want to find the D, how do you find it? Like take any of the term. Like let's see, I taken A3. You just, what you have to do, you just subtract preceding term from this term. The preceding term is A2. So A3 minus A2 is what? 12 minus 10. That is positive 2. It means difference can be positive. Right? Now in this example, let's find the D. Let's take term 2, A2. If I am taking A2, then I have to subtract previous term, that is A1 from this. So it's 10 minus 12. It means D is what? Minus 2. So now in this case, D is negative. So D can be negative as well, positive as well, and 0 as well. Can you give me example of AP which is having difference 0? Yes, we have, like in the previous slides, we considered one. We had taken one example of series, that is 3, 3 and 3. In this case, what is D? 3 minus 3, that is 0. So difference can be 0 also. Fine. Okay. I think all these things are clear to you. Now let's move to the next slide. Yes, here we are. Now just observe this pattern. D, like D is the common difference. I am taking like pink smiley for D, and D is equals to 1. Let's start with, because like any series started with the first term, you can take any term as a first term. So let's suppose A is like this blue smiley is your first term. Then for getting next term, what we do? We just add D, right? This is the format. Like if you want to write 2, 4, 6, what I am doing, you are just adding D, that is 2. Again you are adding D, that is 2. So in this way, like if we will add 1D. 1D is pink smiley, so I added one pink smiley and it's become A plus D. This is your A1, let's suppose first term, A2, A3, A4 and so on. Now for getting A3, it means third term, what we are doing, again we add D to the preceding term, like A2 term. So it becomes D plus D, that is 2D, A plus 2. Fine. Now for finding A4 term, what we do, well, like we add D to the preceding term according to the definition. So it becomes 2D plus D, that is 3D. Fine. So can you observe something in this pattern? Yes. What we are doing, like for finding nth term, like for finding A4, I am adding 4 minus 1, that is 3D. For finding A3 term, I am adding 3 minus 1, that is 2D. For finding A2 term, second term, I am adding 2 minus 1, it means 1. Right? So these kind of patterns, what from this we observe that if you want to find an term, like nth term, like 50th term, 1000 term, 1000 term, lakh term of the same series, then what is your identity, like what is your formula? It's small a represents the first letter, first term, so it's become A plus n minus 1 multiplied D. So this is your first identity to find nth term of the AP series, right? Where A is the first term, n is the number of term, and D is your common difference, right? So if I want to write any, let's suppose 50th term of the series, then it's become what? A plus n minus 1. N is what? 50. So 50 minus 1 multiplied D, that is A plus 49D. It means 1 less than n. N minus 1, that is 3D. Similarly 45 minus 1, that is 49. You just add 49 multiply D to the first term, then you get the 50th term of the series. Fine. So in this way, like you can find nth number, like in the previous slide, starting of the slides, I did some of the situation to find the number of seats in a last row of the theater, or to find the number of logs. So in the any of the rows, so you can use this identity or formula to find them. Fine. Now I think I explained you how you get this identity, because we need to know every explanation of why this identity become, how is this identity become, right? So this is it. Like in this way, you know, this is your like format of, or you can say like series A plus D, A plus 2D, A plus 3D, and at the last term will be A plus n minus 1 into D. Fine. Common difference is clear to you. Like what is common difference? That is the difference between consecutive terms, right? So this is your final identity. Now let's practice some question on the same, how to find like nth term. Fine. So look at this example. Let's take like A is 3 and D is 2. First term is 3 and D is 2, and if I want to find A5, like fifth term of the series, then you just use this identity. Put A is 3, then n minus 1, that is 5 minus 1. D is what? 2. So 5 minus 1 is 4, and 4 multiplied 2 is 8. So 8 plus 3, that is equals to 11. So like you can find this fifth term by adding D also. Like I just started with like 3, 5, 7 plus 2 plus 2 and plus 2. But this is like easy to find up to like maximum 10 numbers, 10th term. But if I ask you to find, like let's find A 50. So so can you you can find it by adding also, but this take lots of time. It's just waste your time. So just use this identity and just find the 50th term within a second. So it become what? A plus n minus 1, that is 49 multiply d. A is given, that is 3, and plus d is what? 2. So it's become 3 plus 9, 49, 2 so 18, 98. So it's become 98, 91, 99, 100, 101. It means of this series, 50th term is 101. Fine. So and see how quickly I calculated the 50th term. Okay. So now this is it for today. The rest of the thing we will discuss in the next class, how to find the sum of the series, where we use some of the questions based on AB, right? And yes, now this is again one of the example. A is what? A is 2 and D is 2. Fine. And N is 12. So you have to find the AN. So AN is 12th term. So in this way, you'll just put the values and at last you get AN is 12. Fine. For the for today, this is it. And yes, one interesting fact. Is Old Faithful Yellowstone National Park. Old Faithful is this one is a glacier where every time Old Faithful is a natural glacier where in a Yellowstone National Park it produces a long eruption that they are easily predicted and surprisingly no one control. This is the natural. It is done by nature only. So what is fact in this? If an eruption lasts 1 minute, then the next eruption will occur is approximately 46 minutes. And if the eruption lasts for 2 minutes, then the next eruption will occur in 58 minutes. So the eruption does occur in the sequence like this, and which is having common difference of 12. So this nature tells you this is a natural AP series. Fine. So this is thinking nature teach us math as well. So this is it. Thank you so much for your time. And yes, if you have any doubt in between, you can ask me or comment me, and I will explain it to you. Thank you so much. Bye bye. Take care.